San Francisco Bay once had 190,000 acres of tidal wetlands, one of the most biodiverse ecosystems on the West Coast. Today, less than 10% of that habitat remains, and one of the biggest forces destroying what's left? Sea levels are rising. Sea level rise is the measurable increase in the average height of the world's oceans, driven largely by the melting of glaciers and ice sheets on land, which alone accounts for nearly 30% of global sea level rise. Glaciers hold 69% of the world's fresh water, and they are disappearing fast. Alaska's McGarty Glacier retreated 9.3 miles in less than a century. The Waits Glacier in Antarctica is melting 5 times faster than in the 1990s, holding enough ice to raise sea levels over 2 feet on its own. In 2024, NASA found sea level rise to be accelerating at a speed of 0.23 inches per year. The driving force is human activity. Burning fossil fuels releases carbon dioxide, trapping heat and speeding up glacial melt and ocean expansion. Rising sea levels doesn't just affect San Francisco either. Ecosystems across the entire planet are paying the price. Coral reefs are bleaching and dying as warming waters alter the chemical balance they depend on. When coral collapses, so does the habitat for thousands of species, triggering a trophic cascade that unravels entire food webs. Coral are a keystone species. Removing them means the biodiversity of the reef collapses with them. On land, coastal forests and wetlands are swallowed by seawater seeping inland, destroying habitats of species that cannot adapt fast enough. Arctic ecosystems collapse as sea ice vanishes. Hundreds of millions of people face flooding, erosion, and permanent loss of land. Sea level rise isn't just a future problem, it is actively reshaping life on Earth right now.
Going back to what my partner mentioned at the beginning, thermal expansion really helps us to understand the actual mechanics of water rising. First, to understand it further, we need to look at the molecular level. First, water molecules, when heated, vibrate faster and push further apart. And since the ocean absorbs almost 90% of the excess atmospheric heat, it expands continuously and noticeably. And this expansion does measurable effects to ecosystems. And to understand that further, we need to look at the ecosystem's trophic levels: producers, then consumers, predators above those. And this energy flows upward. And when the foundation of it breaks, it becomes a trophic cascade, as mentioned before. This cascade is from the rising seas triggering it, and this happens across many ecosystems at once. The science shows that beaches are projected to begin flooding around 2050 for nesting species such as leatherbacks, loggerheads, and green sea turtles. And further, in 2019, the Bramble Cay Milamis became the first mammal confirmed extinct because of the sea levels rising, its habitat being completely swallowed by the water. And this should really give us an idea of how severe the sea levels rising are. And going back to our home, the San Francisco Bay, which originally held 190,000 acres of tidal wetland, now almost 80% of it is gone. These acres were habitats for millions of shorebirds and acted as a storm buffer and water filter. The good thing is that the restoration community has set a target of 1,000 acres for the next 80 years, and over 20,000 acres have already been recovered. And this recovery strategy is a solution. The restored tidal wetlands sequester carbon at up to 10 times higher than the forests. Strategically allowing the land to return to tidal flow has proven effective and scalable in the bay. Every acre that's restored breaks the trophic cascade before it starts. These molecular physics of thermal expansion are already written, but the ecological story, the wetlands, corals, and other species, is still being decided. And it's up to us to save our coastal wetlands and prevent further damage that we have caused to our ecosystem.